the astronauts read out
the gravitational effect of those planets.
Hey, I'm Kristen, and this is NASA Now. Today, you're in for a special treat when we talk with a model who's an expert at making models for NASA. We'll learn about the different types of model craft NASA uses and why tolerance is so important to the design process. That's ahead. First, here's what's happening at NASA Now. You might not know it, but even waste is a factor for deep space exploration. NASA, the U.S. Agency for International Development, the State Department, and Nike announced a challenge. The focus of the challenge is the theme of the Launch Beyond Waste Forum. 10 entrants will be presenting their game-changing innovations that could transform waste management systems and practices. Waste is a fact of life for human beings, and management of waste is important for planning long-range human spaceflight missions to an asteroid, Mars, or beyond. The challenge seeks creative solutions to minimize waste or transform it into new products in space and on Earth. Our guest is Samuel James, a mechanical engineering technician who's also a professional model who works at NASA's Langley Research Center. Samuel's image has appeared in many publications. Today, he joins us to explain the nature of his job at NASA. He is part of a team of experts who develop and fabricate models used to test air and spacecraft. We'll learn why the accuracy of measurement and scale are critical to accurately testing future and current aircraft.
The reason why models are built is because it's very inexpensive. Take, for instance, if you're building a new space vehicle or a new aircraft, it's best to build a smaller model because when you test this vehicle and it's not what you're looking for, you have to go back to the drawing board and recreate or redesign. You have a very fast turnaround time with a model versus a full-size vehicle. So that's why models are very feasible and easy to work with. The engineering design process is the researcher's side of the process with the engineering designers. Basically, they get together, collaborate about a particular design that they're going to come up with and what they want this particular vehicle to do. And when they come up with this design, the material, the drawings are given to us, and then the technicians will review the drawings. Once the model is built, it's then taken out and then into the wind tunnels. The thing about these models, they're actually flown in different wind tunnels. These scale models are not flown in the same wind tunnel. It's built according to what wind tunnel it's flown into. When you're scaling a full-scale aircraft down to a smaller size, everything must be proportional when you're scaling it down. So therefore, you're talking about dynamically scaled aircraft or airplane, and they have to fly like the rear airplane. So when they're put in these tunnels, you're creating an atmosphere or an environment like the full-size aircraft flying outside. That information is given to us from the researcher or the engineer. It's like a computer file, and this file is given to our programmers in our facility. So our NC operators actually cut the high-density foam. It could take anywhere from 1 or 2 days for this profile to be cut out. These molds are made of fiberglass skins and graphite skins. And once these skins are created, we then have a inner structure, a support structure to support these skins. So basically you have two halves. Once you put in the internal parts in both halves, the mold is then bonded together, and then we'll take the molds apart, and then there we have the model itself put together. And then we have other things, cosmetic work to do to it, and then we actually paint the models too. According to what the wind tunnel the model is flown into, it consists of materials such as balsa wood, foam. The bigger models have an aluminum support structure, and we also have the material called honeycomb, which is a man-made material, but it consists of paper and resins, and the technical term for it is called a phenolic. Once the model is finished, our models are measured 3 decimal places, 1/1000th of an inch. We have an XYZ coordinate system on this tracker, and we actually have a ball with a mirror where the mirror can pick up the laser and you can set it at different points or origins on this model, and that's where you start making your measurements from. If the model is built inaccurately, the data that they will receive when they test it in the wind tunnel will be obsolete. You can't really use it.
Now that you've seen how models are created for NASA, here's a chance for you to build your own model aircraft.
Teachers, you and your students can build a test aircraft right in your classroom using everyday items. Look for the Beginner's Guide to Aeronautics, Designing an Aircraft Model activity. You'll find it on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and leave a comment. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.